In probability theory, the Rice distribution or Rician distribution is the probability distribution of the magnitude of a circular bivariate normal random variable with potentially non-zero mean. It was named after Stephen O. Rice. Characterization: the probability density function is where I(O), Z, is the modified Bessel function of the first kind with order 0. The characteristic function is where is one of Horn's confluent hypergeometric functions with two variables and convergent for all finite values of and. It is given by where is the rising factorial. Properties moments the first few raw moments are and, in general, the raw moments are given by. Here LQ, X, denotes a Laguerre polynomial. Where is the confluent hypergeometric function of the first kind? When K is even, the raw moments become simple polynomials in I florin and I 1/2, as in the examples above. For the case Q equals 1/2. The second central moment, the variance, is. Note that indicates the square of the Laguerre polynomial, not the generalized Laguerre polynomial. Differential equation equals. The PDF of the Rice distribution is a solution of the following differential equation. Related distributions, has a Rice distribution if where and are statistically independent normal random variables and is any real number. Another case where comes from the following steps: 1. Generate having a Poisson distribution with parameter, 2. Generate having a chi-squared distribution with 2p plus 2 degrees of freedom. 3. Set. If then has in one central chi-squared distribution with 2 degrees of freedom and one centrality parameter. If then has in one central chi distribution with 2 degrees of freedom and one centrality parameter. If then, that is, for the special case of the Rice distribution given by I 1/2 equals 0, the distribution becomes the Rayleigh distribution, for which the variance is. If then has an exponential distribution. Limiting cases. For large values of the argument, the Laguerre polynomial becomes. It is seen that as I 1/2 becomes large or I florin becomes small, the mean becomes I 1/2 and the variance becomes I 2 florins. Parameter estimation. There are three different methods for estimating the parameters of the Rice distribution: method of moments, method of maximum likelihood, and method of least squares. In the first two methods, the interest is in estimating the parameters of the distribution, I 1/2 and I florin, from a sample of data. This can be done using the method of moments, for example, the sample mean and the sample standard deviation. The sample mean is an estimate of I 1/4 and the sample standard deviation is an estimate of I 1/4 21/2. The following is an efficient method, known as the co-inversion technique for solving the estimating equations, based on the sample mean and the sample standard deviation, simultaneously. This inversion technique is also known as the fixed point formula of SNR. Earlier works on the method of moments usually use a root-finding method to solve the problem, which is not efficient. First, the ratio of the sample mean to the sample standard deviation is defined as R, that is. The fixed point formula of SNR is expressed as where is the ratio of the parameters, that is, and is given by where and are modified Bessel functions of the first kind. Note that is a scaling factor of and is related to by. To find the fixed point, of, an initial solution is selected, that is greater than the lower bound, which is and occurs when. This provides a starting point for the iteration, which uses functional composition, and this continues until is less than some small positive value. Here, denotes the composition of the same function, times. In practice, we associate the final for some integer as the fixed point, that is. Once the fixed point is found, the estimates and are found through the scaling function, as follows. And. To speed up the iteration even more, one can use the Newton's method of root finding. This particular approach is highly efficient. Applications: the Euclidean norm of a bivariate normally distributed random vector. Rician fading, effect of sighting error on target shooting. See also, Rayleigh distribution, Stephen O. Rice. Notes. References: Abramowitz, M. and Stegun, I.A., Handbook of Mathematical Functions, National Bureau of Standards, 1964. Reprinted Dover Publications, 1965. ISBN 0-486-61272-4, Rice, S.O., Mathematical Analysis of Random Noise. Bell System Technical Journal 2446 156. I. Soltani Bose Chal and Ming Liang. A Smoothness Index Guided Approach to Wavelet Parameter Selection in Signal Denoising and Fault Detection. Journal of Sound and Vibration 308, 253 254 doi, 10.1016/JJSV. 2007.07.038. Liu, X. and Hanzo, L. A Unified Exact BER Performance Analysis of Asynchronous DSC-DMA Systems Using BPSK Modulation Over Fading Channels, IEEE Transactions on Wireless Communications, Volume 6, Issue 10, October 2007, pages 3504-3509. Animal I, A, Telembera, C. and Pagava, V.K., Equal Gain Diversity Receiver Performance in Wireless Channels, IEEE Transactions on Communications, Volume 48, October 2000, pages 1732-1745. Erdley, A., Magnus, W., Oberhettinger, F. and Tricormi, F.G., Higher Transcendental Functions, Volume 1. McGraw-Hill Book Company Incorporated, 1953. Srivastava, H. M. and Carlson, P. W., Multiple Gaussian Hypergeometric Series. Ellis Howard Limited, 1985. Sibbers J., Den Decker A. J., Skunders P. and Van Dyke D., Maximum Likelihood Estimation of Rician Distribution Parameters, IEEE Transactions on Medical Imaging, Volume 17, NR3, pages 357-361, Den Decker, A. J., and Sibbers, J. Data Distributions in Magnetic Resonance Images, a Review. Physica Medica 30, 725 €741 doi, 10.1016/JJMP. 2014.05.002. Cow, C.G. and Baser, P.J., Analytically Exact Correction Scheme for Signal Extraction from Noisy Magnitude Mr. Signals, Journal of Magnetic Resonance, Volume 179, Issue = 2, pages 317-322, Abdi, A., Tepetlanlioglu, C., Carver, M., and Giannikis, G. on the Estimation of the K-Parameter for the Rice Fading Distribution, IEEE Communications Letters, Volume 5, Number 3, March 2001, pages 92-94. Talukder, K.K., and Loing, William D. Estimation of the Parameters of the Rice Distribution. Journal of the Acoustical Society of America 89, 1193-1197. doi, 10.1121/1.400532. Bonney, J. M., Renner, J. P., and Zanker, M. Optimal Measurement of Magnitude and Phase from MR Data. Journal of Magnetic Resonance, Series B 113, 136-144 doi, 10.1006/JMB. 1996.0166. External links, MATLAB code for Rice-Rician distribution.